Hello dear student, I am Ashish Uddhav Shende, Assistant Professor, Rashtrapita Mahatma Gandhi College Savli, Department of Physics. Today I am going to explain the second topic of this bridge course, center of mass. We know that the Newton's laws of motions, the first, second and third laws. Initially, we started from the definition of center of mass. The center of mass of a body is defined as the point at which the whole mass of the body is supposed to be concentrated in order to study the motion of the body due to an external forces in accordance with the Newton's law of motion. There are two types of forces, internal and external. The internal forces are forces between an object within the system and another object within the system. External forces are forces between the object within the system and an object outside the system. This diagram shows that when the body is thrown in upward directions, the body will be motion at different point, but the center of mass of that body is along a path. This another images shows that when the body is in motion, the body part also in motion, but the mass of that body is supposed to be concentrated in one point. Here see that the head path of head and the path of center mass. That means the according to definition, the center of mass of body is such a point at which the whole mass of the body is supposed to be concentrated, and the another mass of the body is distributed in a small piece of masses. So this is the equation of position, velocity and acceleration of center of mass. Here capital M is indicated that the resultant mass of that body, and small mn it shows that the mass which will be distributed in a small pieces. Xn, that is the position vector. Here also Vcm, that is the velocity of center of mass, and Acm, that is acceleration of center of mass. Now the momentum, we know that when a particle is in a translation motion, the momentum is mass into, it is a product of mass into velocity, where momentum is a vector quantity and its direction is the same as the object velocity. Momentum must be added as a vector. Now the conservation of momentum. We know that the Newton's second law of motion, which state that the force is directly proportional to the rate of change of momentum. For this system, only external force which will be act, and therefore external force that change the momentum, and therefore this equation summation of external force is equal to the rate of change of momentum with respect to time. If the sum of the external forces is 0, then the total momentum is also 0. We state that the momentum does not change over time, that is, it is constant and it is conserved If you know that the momentum at any one time, then you know it for all other times. Thank you.